Oh, good morning, everybody. Well, it's another Sunday morning, and yesterday was a successful test run of the outboard motor, and so the next thing I've got to move on to here is the lower gear case assembly. So I've just been reading up here in this book that I picked up at the library. That's coming really handy so far. This is the Outboard Motor Service Manual 11th edition by Intertech. This is volume 2 and covers the inline 6. And there's only one chapter in the whole book, one section in the whole book on the inline 6. But what small amount of the book is on the inline 6 is packed with a lot of good information. So what I'm going to end up having to do is put away all of my tools and everything that I had out for working on the motor, kind of clean up the bench here, and we'll get the gear case up here and we'll start disassembly on that, because that gear case is one sick puppy. It was probably a running gear case, and then I think water got in it and it froze and it cracked the case, and I can't weld it because I'm worried about the heat destroying all of the seals and everything in there. There's actually a complete exploded view parts breakdown here. You know, if we can, if we, me and the mouse in my pocket, if we can affect a good repair on the case, then we'll put a new water pump impeller on it, and we'll put it back on the motor, and we'll, you know, hopefully we'll have a good usable running machine. So I'm going to finish my coffee and finish reading up on this. I'm going to read this whole thing through before I even start doing anything. Just out of curiosity, I'm wondering how many of you guys thought I was never going to get that motor running. Because I'll tell you, I had my doubts myself. I mean, logically, I had no reason to suspect that it wouldn't run. I had compression, I had spark, I had cleaned the fuel systems, clean as a whistle. So I had no reason to think it wasn't going to work, but I was still surprised when it got running, and when it started, you know, when it started really starting to smooth out in that. I'm still I'm still pretty happy about it. So the first thing I want to do is I want to take off the prop, and to take the prop off, you have to remove this nut, and this nut has this special locking ring. There's a metal ring here that actually has a shape of the nut that the hex nut sits in, and so this special ring has to turn with the nut, but it has these metal tabs which are bent down into these slots right here, and that's what locks this ring. So because the ring is locked and can't turn, that's what keeps this from loosening up, hopefully. So before you can loosen that up, you have to pry these tabs that are locked into the slots out. Now, it's interesting to me that I noticed that of the 6 tabs that are on here, only 2 of them are bent down. So I don't know whether or not somebody figured 2 was enough, or whether or not it's commonplace to not bend all of them down. Boy, these are a lot. These are a lot tougher than I thought they'd be. That is not some chintzy little metal that they're using on these things. I don't want to break this lip right here. I'd like to think that would be pretty difficult to do, but... Alright, let me get a thinner blade screwdriver. Alright, let's see. That wasn't working out too well. I've got this seal removal tool. Let me see if this will... That's the ticket. Well, that's a good tool to use on this thing. Oh, nice. Alright. Now, that book actually suggests wedging a wood block between the propeller blade and the anti-ventilation plate. Okay, anti-ventilation plate. Honest to goodness, that's what it says. There are no pictures that show the wood block being placed in a place where it can do what they're suggesting it does. So, I'm kind of at a loss here because, you know, maybe if you're an outboard expert, you know what an anti-ventilation plate is. Anti-ventilation plate, that even just sounds weird to me. I could see like something being called maybe an anti-cavitation plate. But, you know, this whole assembly here, this body of it is the Gearcase housing. So part of the Gearcase housing, I know that like they call this the skeg. Okay. So I'm wondering if this wing right here is the anti-ventilation plate. Because I'm looking at how I'm going to put this in here and stop this from turning. And it just seems to make sense to me that it's either going to go in here up against this, which I think is just more just the main housing, or in here up against this whole thing up here. So this is what I think they mean, and hopefully this isn't too tight. Hopefully it's not reverse thread either. Hopefully it's, you know, not a left-handed thread. Oh heck, that wasn't even very tight at all. Well, I guess they do rely on that locking ring to do a lot of the locking for you, huh? This is a self-locking nut too, by the looks of it. Okay, so now I've got to make note very specifically of the order of assembly of the stuff I'm about to take off. So we have the nut, we have the locking washer, we have the prop, we have this large spacer. Okay, this large spacer appears to be perfectly flat on this side, which is facing toward the end of the shaft. It appears to have and it definitely does, it has a chamfered edge right here that appears to face against here. That might be all that that might be all that comes off at this point. Obviously there's a special tool that is used to remove this locking ring. Well, I'm getting ahead of myself. Let's Alright, so now I've got the Gearcase on the bench. I've got it in a vise. You should clamp it in a soft jaw vise. In my case, my soft jaws are the dirty sock. Well, it's dirty because it's greasy. It's not like it's a smelly foot sock. Anyways, that keeps the jaws of the vise from digging into this soft aluminum. So the next step I'm going to do is I'm going to drain the Gearcase. Now, an experienced outboard technician would be able to tell a lot about the condition of a Gearcase just based on what they find when we do this next step. You know, what we would like to find would be nice clean oil coming out of there, and very little evidence of any water or moisture. We don't want milky fluid, which would indicate that water has emulsified into the oil. We don't want just straight water coming out. That's real bad. Rust. The presence of anything that would indicate rust in the water, also very bad. It's just, or barely any oil in there at all would also be a bad thing. So I've got my little drain bucket here. I got an extra one in case, but I got a feeling that this is already a little dirty, so I'm not really looking to see what the presence of dirt is. I'm looking to see what the presence and condition of the fluid that's in there. Alright, so when I take this out, it's not going to really drain really well. Up here there's a second plug. This is your vent. What happens is if this is air and water tight, which you like to think it is, it doesn't drain really well until you open this vent one, and then it should start to drain pretty well. So let's zoom in and get a look at what comes out of this mess. Nothing. Now I didn't open the vent yet, but still, I mean, it should be dribbling. Vent's out, bone dry. Question is it bone dry because after it cracked, it all leaked out? Or is it bone dry because something else went wrong and this thing was just, you know, run dry? It's not at all what I was hoping to see. This is kind of interesting. Normally, there's a plastic washer. There's some sort of a washer or a seal on these little plugs. And I don't see one, so if it's not stuck here, then they're missing. Oh, there it is. So you want to replace these whenever you do a fluid change. There should be one up here on the vent too. And there is. Okay, so I got some more light on the subject here. See if I can't figure out how the hell this is. Well, it appears that there's a seal right there. If I'm reading this correctly from what the manual's telling me, the next step in disassembly appears to be the removal of this large nut. Look at this really big nut right here. Now obviously there's a very special tool that goes in there. It's probably the holy cow tool, because you probably say holy cow when you find out how much it costs. Well, I'm thinking I could probably make this tool. I got a lathe and a milling machine. And really I just need to make something that will sit in here and have a couple of, maybe even just two little dogs that will engage a couple of these slots across from each other, and then have something on that very same ring that will allow me to put a more conventional tool on there. All right? I guess I could actually see how much it costs to buy one of these tools online. Well, I don't know if this is going to show up, but I just googled Mercury Outboard retaining nut tool, and that looks like the correct tool there. It's $86 on eBay there, $84 on jet.com. That's a different one. Sierra, $83. Cruiser Alpha Drive, $80. Alright, so right here there's a metal tab, and it appears that the purpose of this metal tab is to actually sit in this slot right here and act as a lock, so that this nut can't loosen on its own. Bending it up gently, trying not to break it in case it's part of the carrier. That should be enough. I'm just running this pick, this sharp scribe around the outside edge in that groove. There is some corrosion in there. Just for the heck of it, I'm going to try and tap this ring and see if it actually moves. You know, depending on how tight it is, I might not need the tool. I can't tell if that's moving or if the whole thing's moving. And judging from all the corrosion I see here, there's no reason to believe that that's not going to be seized in there pretty tight. I may very well need not only a tool, but also maybe an application of some heat to this thing to get things moving. Well, I figure one of the things I can do is I can clean up these grooves. I was making so much dust I decided to run my shop vac to get rid of some of it. Well, upon further inspection, I noticed the word off right here. And then right over here there's an arrow that actually points that direction, which would indicate that this unscrews counterclockwise, so it's not a reverse thread or anything like that. There's also up in the upper corner here, there's a part number for the actual, probably for the nut itself. Well, in preparation for removal, in addition to cleaning out these threads, which I just did, and moving that tab out of the way, I think I'm going to use some PB Blaster on here. Figure it won't hurt to let that soak. And I'm going to just lay it down on its side like that and let the gravity help that PB Blaster penetrant work its way in. Well, it's been a day since I left this to soak, and before I go ahead and start the project of actually making the tool to unscrew this, I want to try and see if I just can't get this to move at all. I got a piece of brass here to protect the because yesterday I was tapping on it with the screwdriver and it actually started to dig right into the nut there, so that metal is pretty soft. Boy, that metal is really soft. The brass is actually putting a dent in it, so doesn't look like that's going to be the answer. Gonna have to do this the harder way, which is make myself a tool. Well, I've decided I'm going to construct a tool to take out this nut. And I was looking around in the workshop trying to figure out what I was going to make it out of. I had this big hunk of steel here, but if I make it out of this, it'll be an incredible waste of a nice, good-sized hunk. I was going through my piles of stuff and everything, and I came across this bearing carrier assembly. It's kind of a weird thing that I had two of these. They came with my Wells Index milling machine. They were in the cabinet, that all the stuff that was in the cabinet came with the milling machine. There was a lot of milling machine items in there, but there was a lot of just odd stuff in there too, and these were in there. So I already removed the bearings that were in it and some of the other pieces that went to it. This is the piece that went in the center. So I'm not quite sure what these were used for originally, but as luck would have it, I just checked it out, and this dimension right here is almost perfect for our purposes here of making this. It's actually just a little bit under, but it'll work. So by using this piece, I won't have to do any lathe work at all. I can basically I'll set this up in the milling machine. I'll mill out some material here and leave 4 equidistantly spaced little nubs that will engage this nut. Then I'm just going to figure out how I'm going to hold on to this. I'm actually, for starters, I'm probably just going to put a big old pipe wrench on this thing and see if that doesn't work. If that doesn't work, then maybe I'll have to come up with a whole nother plan of action. I was even thinking of maybe I could even put a hole in this thing for this type of wrench here. So that's an option. If I it comes down to it. So for starters, I gotta get this thing in the milling machine. I think what I'm going to do is, I think I'm going to mount it on the rotary table. I already have my rotary table mounted on the machine from the last time I did something, so since it's already there and all set to go, I'm going to do that, but I'm debating whether or not I want to mill off this lip. Because if I mill off this lip, then this will lay really flat and I can really clamp down on it. I should be able to clamp down on that without doing that. That's an extra operation I don't need to do, I don't think. Alright, so I want to clamp this down and I want it centered on my table, on my rotary table. So for starters, I just use a scale and I get it roughly in position. So like that's, we'll call that 2 7/8. Alright, now that I've got it close by eyeballing and using a scale, I'm going to get it dialed in. I've got an indicator on here, and I've got my indicator on, and I've got I'm picking a point right here. I've set the indicator to 0, and this is showing me 50 degrees. And what I want to do is I want to come around to this side, 180 degrees exactly opposite, and see what the difference in deflection is. And then I'm going to split the difference, and that'll get it in one direction. And then I'll go 90 degrees. So I'll be perpendicular to those 2 points and do it again, and that should bring me pretty darn close. Probably close enough for my needs for this operation anyways. So I got this set to 0. I've got some tape here. This is my no man's land. I don't want the indicator to try, this point on the indicator to try and go anywhere where this white tape is, because I know I've already checked, those are my limits where these clamps are going to get in the way and cause a problem. I've only got a couple of clamps on there now because I want to be able to move that thing around, and then once I get it dialed in, I'll probably put another clamp on the other side. So 50 degrees, and I want to go 180 degrees back the other way. Well, I didn't like how that was working out, so I changed my setup. I've got my indicator on the inside, and as long as that inner circumference is concentric to the outer circumference, which I'm almost positive it is because this is a bearing carrier, so it had to be pretty precise, that should work. And I've got my arm clear enough so that I've got the clamps not impinging, so I can go a full 360 degrees now and measure the entire run out. And it's only about a 1.5 to 2,000th over the whole diameter. So I at that point I tightened down my clamps, and that feels pretty good. So the next thing I think I'm going to do is I'm going to determine what size cutter I want to use. I can't use a big face mill like I just had in there because I won't be able to fit it. Once I have 2 lugs made here and here, when I'm making my passes through here, if the cutter's too wide, it's going to hit my new lugs. So the maximum diameter of the cutter that I could use would be this inner diameter right here. Okay. So that inner diameter, 2.440, scratch that, 2.435. So 2.435
minus the width of the lugs that I'm making, and then that remainder divided by 2.
All right, so I got in the ballpark, and now I've mounted an indicator on the collet. This is my best test indicator, and I've got this pretty close now. So I'm just going to zero it in a little bit as soon as I find my glasses. So let's see, that's almost on the 0 right there. Standing right in front of the camera the whole time. Alright, well, anyway, so I could sweep around and I could stay within 1 division, which is on this dial is 0.5 So that's plenty close enough accuracy for what, the tool that I'm making. So I'm going to lock my y-axes. Alright, so now I've got my setup here. This is a longer end mill than I would like to use, but it's one of the few 1-inch end mills I can find on hand. I know I've got some others around here, but I'll just use this to get this job done. And so I've got it in this holder, this R8 holder, which can accommodate the 1-inch shank. So right now I've got that 1-inch cutter, I've got that centered right dead center in the middle there. So for my first cut, I'm going to be making my passes left to right for the first cuts. So what I want to do, in reality what I want to do is I've got to offset that cutter, take into account the diameter of the cutter, and then also I want to offset it half the width of my piece that I want to leave behind. So if that makes sense, hopefully that makes sense to people, because I think I'm confusing myself. Well, it's a good time to quit for tonight.